Hey, what's going YouTube? Your boy Zane is back with another video tutorial of a challenge called Scissors Cipher. Right, let's get some cipherism on. Yeah, that's just a word I've just literally 1 second ago invented. Anyway, back to the challenge. So it says one of the simplest and most widely known ciphers is Caesar's Caesar, right? Also known as a shift cipher. In the shift cipher, the meaning of the letters are shifted by some set amount. Cool. A common modern use is the ROT13 cipher, where the values of the letters are shifted by 13 places. Thus, A becomes N and and B becomes 0. I mean, oh, sorry, my apologies, and so on. So now it says write a function which takes a raw13 encoded string, which is this one here, as input and returns a decoded string. All letters will be uppercase. Do not transform any non-alphabetic characters, that is spaces, punctuation, but do pass them on. So it's saying to ignore the space, ignore the spaces and punctuation. So we're not going to be converting those punctuations and spaces instead. We're gonna just leave them as they are, right? And it said remember to use research and ask if you get stuck, pair programming or write your own code. Alright, cool. So now you first of all you must be wondering, hang on Zane, what's our rot 13 cipher? Okay, so basically what rot 13 is a simple letter substitution cipher that replaces a letter with 13th letter after it. So it's essentially the it shifts the current value to become, I mean the current letter to become the letter that's 13 places after it. Okay, so in which A becomes N and B becomes 0. And I need to acknowledge one thing, that the definition that I just told you about ROT13 is from the Wikipedia. So, okay. So now I'll just demonstrate you what I mean by adding 13 places. And so suppose we have all these alphabets, okay? C, D, E, F. Actually, I'll just copy and paste it from my notepad. Here we go. Okay, cool. So see, that's all the alphabets, and by 13 places after A, suppose that our letter is A, and we're we're gonna be applying rot 13 to it. So A will become N. How is you're gonna add 13 places after A. So A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Similarly for B, B will become 0 and C will become P. So C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, no, 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 no. So C will become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, I was right. So C will become P, B will become 0, and A will become N. So how are we approaching this thought? So in this challenge, we're going to be using the ASCII table. So the ASCII table is the American Standard Code for information interchange. Alright, so American Standard Code for information interchange, which means this table here. So every character has its numerical value. For example, you have got everything: space, punctuations, um, currency formats, numbers as well, uh, da, 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 uppercase letters, these symbols, and these small letters as well, and these all represent this case here. So these are all the ASCII codes for them. Alright, starting from 65 until 90, A to Z. Alright, and these are the lowercase, but in this challenge, because we only need all the uppercases, so we're just gonna be focusing on 65 until 90. Alright, cool. So now that that's out of the way, so how we gonna approach this challenge by iterating through each of these letters. So to simplify things, initially I will just oops I will just work with one letter uh, at a time. So say this one can be commented out, and this one can be, I don't know, E. Right, cool. And I need to comment these out as well. Alright, sweet. Okay, so first of all, how we gonna iterate through them by creating a for loop. So the typical one, for I 0 I less than string dot length, and then I plus plus. Okay, and now what we need is the ASCII code for the current string. There we have, or you can say the current character. I mean, alright. How are we gonna do that? By creating a variable first, ASCII number, and I'll say ASCII code, and then I will take the current value of the array, which is the string, obviously, and I will apply the method called car code at. Okay, so what this what this method does is it takes a alphabet and converts it into a ASCII code. Alright, so now that we have the ASCII code there. Let's we need to check if the ASCII code is between 65 and 90. All right, how are we gonna do that? By if statement. So we're gonna say if ASCII code is greater than or equal to 65 and ASCII code is less than or equal to 90. All right, so we're just seeing in this all uppercase uh, characters. All right, so if it is in this range, then what we want to do is we want to get the letter from the code and save it in our variable. In that case, we're gonna create another variable, and what shall we name it as? I would say decoded letter. All right, and so put the equal to empty string. So decoded letter would be string, and then I will apply another string method called from car code, and then I will pass it the ASCII code, and then because we need the 13 places, I mean we need the letter to be 13 places after the particular passing letter, so we're gonna add 13 to that particular letter's ASCII code. All right, so in this case it's E, so we're converting E to ASCII code, to code. In this case, first let's check what would be the value of ASCII code, and if that matches our correct value. Alright, 69, so E should be 69 here. E, yeah, here we go, 69, perfect. So we're just converting the letter, so 69 plus 13, 69 plus 13 is 82. So we should be getting R, alright, instead of A. Let's have a look if we get that or not. So console.log, alright, that one's done. And yeah, decoded letter, and we should get from R, alright, because 82, which is 69 of the ASCII code was console.log ASCII code. Okay, so 69 plus 13 was 82, and then the value, the alphabet the character that's on 82 is R, right? And we are getting R over here, alright? Perfect. And let's test another value, say G. What do we get? So if it's G, we should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. T in this case. Do we get that? Let's see. Um, Decoded G T. Yeah. All right. Perfect. Now that we know that that's perfect, working perfectly fine. So now there's one problem here. The problem is that whenever we have more than one character here, then it would be replaced by the previous character. So what we want to do is keep adding to the previous characters as well. I mean, keep adding our new characters to the previous characters as well. Okay, and how we're gonna do that? By adding a plus here. Alright, cool. So now there's another problem that if we give in a, a W, what do we get? Let's see. Console.log decoded letter. Well, we get nothing, to be honest. Yeah. Actually, why didn't it come up with a output here? What did I type in? I typed in lowercase, but hang on. That's not right because if we pass in W, then it should give us something else, but not D for sure. Right, so in this case, it gives us D, right? Yeah, cool. And the reason why is giving us D, which is an incorrect output for us, but it's right because what we have told the program is because it's adding, say W is 87 is, so it's adding 87 plus 13 equals 100, and what's 100 in this sequence? 100 is lowercase d. So what we need to do is come somewhere in the middle here, which is m, alright, and which is probably yes 77, and then say if ASCII code is greater than 65 and ASCII code is less than 77, alright, then we want to have this statement executed. Otherwise, else if ASCII code, I'll just copy and paste it. It's a lot quicker and easier as well. So ASCII code is um 77. So if in this case ASCII code is greater than or equal to 77 and less than equal to 90, then we basically want to subtract the subtract 13 from the ASCII code. So in this case, what's gonna happen is that instead of going forward, it will come backwards. Alright, so if it's a W, so it will go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So in this case, the output should be 74, which is a J. Let's have a look if it is that. W, why is this coming up? Else if, yeah, 87, and then I will dot console log it to decoded letter J. Yep. Why did that happen? Because um not this one. That was because W, which is 87, so 87 minus 13 was 74. So in this case, 74 was of the value J. Alright? I mean, of the car J. So we have a J here. Perfect. Now this scenario is done as well, and we probably have to cover one more scenario in which, so in short, uh, what I mean by subtract is that we're going backwards. So it's W here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If it's say X, then it would the decoding letter would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. K. Let's see if it's K. Oops. Decoded letter K. Perfect. If we have say Z, then our decoding letter is M, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect. So now that this scenario is outgone as well.
So now let's
Right, so I think that should be it. Oops, please guys remember to add the plus sign here because that's really important. Why? Because if you don't, then you would forget the previous character that is already added, and you will only get one character each time. So Z, so in this case, you would get S, and then S will fly away, and then E will come on its place. E will fly away, and then R will come to its place, so on and so forth. Alright, so this plus sign is really important. Alright, so let's see if we pass this test. I'll just do this. Right, so I will remove this one and all my console statements as well and run the test. I should decode free code camp. Okay, cool. So I think that's not really adding spaces. Let's see if it is or not. Decoded letters, decoded letters. Yep, it's not adding this. Oops, my bad. I was supposed to do it here. Yep, it's not adding that it's not adding space to there, which it should be. So what we're gonna do is we're gonna just keep passing the punctuations onwards. So in that case, what we're gonna do is we're going to include an else statement and say that, oops, no, what am I doing here? What am I doing here? I'm going nuts, I think. Yep. Uh-oh. Right, so this one ends it. So else, so I'm gonna say that if my um so basically else statement specifies that if I've got any other ASCII codes except these ones here, which is 65 to 90, then I will just be adding those where's my string? Yep, that's string, the value to my decoded letters as it is. I won't make any change at all whatsoever. I'll just write the value which is here. For, for example, it can be exclamation mark, space, question mark. I'll add that straight in the decoded letter. So say for example we have exclamation mark here, then exclamation mark will be added here. A question mark here, a question mark is here as well. Perfect. Alright guys, whoa, this video has been extremely longer than I expected. I'll just stop here, and if you guys have any questions, feel free to comment. And oh yeah, by the way, we need to write our the returns. We need to return the decoding letters as well. Alright, otherwise you won't pass the test at all. I can show you what I mean. Say if I have string here still, I'm not gonna pass it. Impossible. So we need to have decoding letter here, and then we will pass it. Yay! Get to the chopper. Alright guys, hope you learned a lot. Sorry about this video. It's gone extremely longer than I actually expected, but hopefully you guys learned a lot from it, and I'll see you guys in the next video, which is tomorrow. So stay tuned and have fun coding.